Okie doke. It's time to go. My sleep was whack yet again the day before yesterday because all these outlier days, fucking job interview, fucking the next day having to recover from it, the next day staying up late because hanging out with a buddy, I don't get to hang out much. And then the fucking next day, which was yesterday, and yesterday was recovering from that. And now today, I'm good. Let's get it. Part 1, learning. Let me update my timers really quick. Break in an hour and 30 minutes from now. Excuse me, the break will last 30 minutes. And then I'll finish up another hour and 30 minutes from then. So, gotta stay up 40 minutes past bedtime, but it's okay. Okie dokie. So we can use auto for this because there aren't conversions. So like in cases where we are returning a standard string, or well, in a case where I'm returning, so is the point, well, oh, well, oh, I think the point here is saying, hey, this doesn't need an entire copy of this standard string view. Because what we're doing is we're getting a standard string somewhere. But this function is weird because we shouldn't be returning a standard string because unless we're updating a global variable and returning a string view to it, which we totally could, and that could be totally fine, we might be returning a string view to a local variable. And if that's the case, when we return it, hold on, I'm about to sneeze. Oh, excuse me. Can't mute anything on here. I don't have a mute button. Let's see. If we have a function, we're getting a standard string. Yeah, I mean, in order to get a standard string from the player, we have to have a standard string variable. We extract input to it, and then we return, in this case, it looks like a string view to it. What that means is we're returning a view of wherever that string is in memory. And the problem here is that after we return that value, when we try and access it, if anything has changed there, which it totally may at any given time, the value might be fucked up and inaccurate. So we don't want to turn a string view to a variable that no longer exists. Because sure, the value may be left over there, just like a value could be left over anywhere in memory when we instantiate an object at that place in memory. Well, the remaining value is still there. In this case, when we look back, and later on we look back here, it's still there. It might be, but it might be changed. In this case, we can get around it by initializing. Oh, maybe it's actually not even bad here because we're not taking that information and then doing something with it and then looking at it later. We're actually taking that information and copying it straight here to initialize S1, standard string. Actually, I think that's okay. I think so. The problem, though, is that we are converting a standard string view. So a standard string view I gotta sneeze again. Oh, excuse me. I'm trying to think of what data a standard string view is. I'm about to sneeze a third time. Excuse me. It seems like a standard string view is a view of an existing string, but in read-only format. So it seems like it is actually stored somewhere else. And I think that means that we actually have to copy the value from the string view. I think it's like copying an Excel spreadsheet somewhere else and making it read-only. So sure, it has the same information, but it's read-only and it's cheaper, maybe. So in this case, if this information is literally a string view type, once it gets here, the return value of getString, throat has a bunch of phlegm in it now because I coughed, or sneezed. Sneezed and coughed, actually. So, if we're initializing S1, this string here, I think that means that we have to convert from the string view information to a standard string. In this case, however, if we had just chosen auto, instead of converting, yes, this is right, from a string view to a standard string. Instead, because I think string view information is like the same as standard string, so I think the passing is okay, but the assignment part of this is difficult. So like if we said if, and then getString or something, or like if whatever, and it calls that, I think it's okay because we're not copying it anywhere. We're just evaluating it. But in this case, because we're copying it to a standard string, we have to convert something to a standard string, which means we're dealing with standard string information, which is expensive to pass to other places because of copying. Copying is expensive. In this case, instead, auto S2, I believe, would be deduced to be of the same type of standard string, or of getString. Well, getString's output is a standard string view. Therefore, the return type is a standard string view. Therefore, auto should deduce that S2 should actually be of standard string view type. So yes, there is no conversion required exactly. Cool. Also has downsides. Yeah, it obscures the type because we can't. I had to do all this just to figure this out. Instead, you could have just done standard string view because you know this. It feels like if there wasn't a programmer and code was just code, and I said, hey, do this, it seems like it would be totally fine for everything to say auto. But because there's a programmer behind the code who needs to maintain it and thus understand it, it seems like auto is obscuring the meaning of the code and how much understanding is required to properly change, understand, and improve it. Because it would take me a second to realize, oh yes, auto getString. getString returns a string, right? Because of whatever. Well, now I have to go and check and see, oh, it's actually string view. And then, oh, that means this is a string view because it's auto. Instead of saying, oh, this is getString. Oh, this is a standard string view it's returning. Let me just update this to be a standard string view. Cool. Thus it's clear that this is a standard string view. But in here, I don't know if there's conversion happening here automatically or anything. It feels like it's hiding the info. I guess you say the point here is that there are no unintended performance impacting conversions. But I'm wondering if there are any cases where deduction chooses an unoptimal or less optimal data type. Like maybe so far it's been okay. It's been fine, I think, initializing any type of integer with a positive value. So if we have like an int 64t, and I initialize it with the value of 60, and 60 is an integer literal, it's going to undergo numeric promotion. Let me think of y really quick. Well, no, because it's not implicit. Yeah. I guess it will. Oh, God. It's been two days since I've tested on this stuff. I've already forgotten. That's stupid. So the point is that the destination type is an int64, and the parameter / initial type is an integer. Thus, to resolve the type difference there, the integer value is promoted into the same type, assuming it's already of the same base type, like an integer to an integer, or like a float to a double, or a short to an int to an int 32, an int to an int 64 from an int 32, etc. So if I initialized an int 64 with a small number, it'd be okay, because, or if I had a function that returns a small number, like let's say let's say I'm writing the parameters, or the the properties of a boss, and I write that the boss has, or the boss starts with 1,000 health. Well, if I initialize an int 64 to 1,000, and the reason here is because the boss's health can increase much above 64, and I need a variable that has room to store so much. I mean, in this case, an int 64 is probably overkill. I think we're getting into the quintillions here. But we could say I mean, by default, it's an int. So let's say it's an int 64, or at least a long. So I could say long boss health is initialized 100. The reason why I'm initializing it as 100 or as 1,000 is because it can actually go all the way up into the millions. Maybe it's a game like Risk of Rain or something where the numbers are just huge. So you see the boss and you're like, oh, it only has 1,000. Oh yeah. Let's say it's a boss that goes through phases. So there's a boss and it's like a little worm on the ground. And in the boss fight, or when the boss fight starts, let's say it's a game where you can see the health bars. Or it's something like Dark Souls kind of. So you can see this little tiny bar on the bottom of the screen. It's a little tiny boss health bar. And it looks like it would only be about 1,000 health compared to millions. So it's this little teeny tiny bar, much smaller than the other boss health that you've seen. And we use an auto to be the type of the boss health, and we initialize it to be 1,000 because the little worm guy only has 1,000 health. But the point is that the guy can actually go all the way up to a freaking quintillion health, which is an int 64. So if I initialize auto boss health with 1,000, well, it'll say, hey, this integer literal 1,000 is only an integer. Therefore, the type deduction should be that auto should actually be an integer, and therefore the boss health is an integer. Therefore, it's going to cap out at, I think it's like 1.15 billion. Well, it turns out that this is a Risk of Rain kind of game where people can do millions of damage in a second, or maybe even, we'll say, 1 billion damage. So a quintillion is a lot of health, but 1 billion is not a whole lot of health for a geared guy. Well, in this case, if you can only have 1 billion, or like 1.15 billion health, that's not very much. So the act of using type deduction here is actually giving you wrong functionality. I would want to comment on the right side saying, hey, this actually needs to be a long. That way it's 100% or an int64t to 100% be an int64 because the boss health needs to be able to go all the way up to whatever, 8 or probably 4 because it's assigned int, 4 quintillion. So we need to use an int64. If we use an auto, well, the character is going to do so much damage that when the boss's health, or when the boss takes damage, let's say it takes 2 billion damage. Well, 2 billion is more than the signed negative value, or is more negative. So an integer minus, well, maybe not, because if he has that much health, yeah, let's say you can do 3 billion. So if a regular int 32, or an int rather, well, same shit, has or goes up to 1.15 billion. It goes down to negative 1.15 billion. But if you take 3 billion damage, we're actually still going to get wraparound here. So we're going to say he's at 1.15 billion. So the worm's going to go from 1,000 health, and he's going to heal up, and the boss fight's going to start. He goes up to 1.15 billion health. But then you do 3 billion damage to him. So it does 1.15 billion damage to get him to 0, and then it does another 1.15 billion damage to get him to negative 1.15 billion. Well, you still have 700 million damage to do. And if you continue doing that, you're actually going to do modular wraparound, and you're going to go back up to 1.15 billion, which means when you subtract that 700 million, you're going to get like 3.15, or maybe 4.15 million health still left over. Which means you just killed the guy back into existence. You just reduced his entire health and went all the way negative, unless you have some sort of check to make sure that, hey, the second it goes down to 0, he's dead. In short, the problem here is that the integer type was not correct. It didn't see the forest for the trees. It only saw one tree. It didn't see the entire forest, the entire purpose of the trees and what's going on in this context. It only saw hay. Because of this value, it must be this type. No. We actually need a value. We need a type that can hold much, much more than the type of this value. So much more that this value actually has to be numerically promoted to even be used to initialize this type. That's what we were missing there. So it obscures an object's type information on the code. Should be able to show you that. Oh, all right, let's see. Does it work? God, I always get tired after eating here and sitting in this chair, bro. This chair is so comfortable. It's hard. Oh, good. Update on clothes. It's a good feature. Oops. Too far. It's too hot. Take off my shirt for a second. Oh, yeah, it's too hot for sure. Excuse me. Okay. So if we had auto boss health. Oops. Let's just say it was 100. I could hover over boss health, and it will say int. But if I instead had done a huge number, well, it's now a long. So you can actually see that the type of the boss health is determined by this integer value. It's a long literal. But if we instead do this, oh, now it's just a regular int. And it won't get any smaller than that, I don't think. Well, don't int. Does it have to be more than 1 digit to see the type, or am I just not hovering properly? I guess you can't if it's 1. Well, I mean, we can see exactly what I was doing there. But okay, so we could have so we'll say oh, we don't even have a standard string. Well, that's actually a good way to bypass the IntelliSense predictor thing. Right, so instead, I'm just going to do a constant auto. Name care name. It'll be what the fuck? Why did I do Steven? Sure, it's not referenced, but and it is it's actually saving it as a character, a constant character pointer. So, interesting. Seems like it's a pointer to a pointer of constant characters. It seems like that's what this means. If I instead just did standard string, then obviously it would be a standard string. Yeah, that is what it meant earlier when it was a const pointer to a constant character, or at least a grouping of them. Auto 5. Yeah, exactly. Yeah, see? And maybe you want a double initialized with 5. But you just forget to do double because you're in the habit of doing auto. Or, yeah, if it's the case where you want to create boss health and boss health needs to be a float for some reason, well, you have to explicitly make it a float, so you can't just be in the habit of using whatever. Or you either have to be, you either have to change it, or you have to be in the habit of using only the literals. Like earlier, I think we have to include some sort of header file to get all the suffixes, some part of the standard namespace. That way we can get I64. It looked like that was the suffix for an integer that's so large. Here. Yeah, it forces you to be more, you use it to be less careful about the type, yet you have to be more careful about the initializer. I dislike that. Thus, that's why it tells you that the best practice later is use auto when you don't care about the type. Well, a lot of times we probably do care about the type, just like for boss health. I don't want the health to be able to be too large, or rather, I guess we don't even ever say that. Like N64 is probably always fine. We don't want wraparound, but I specifically need the health to be large enough, and I don't want fucking wraparound, so I have to declare it, or give it a data type that can fit that value. X and Y, this and this. We wanted floating point division here. So now you have to go in and be careful with your literals. Or just be explicit with your floats. And you get 1.5. Or, yes. What? Well, it's not less clear, it's obvious. These are integers. Meaning you want an operation to happen with signed values. You have to make sure that, yeah. You have to make sure that the values are signed or unsigned. This auto might not do it properly. I mean, it seems like auto just defaults to int. But if you specifically want an unsigned int, perhaps for wraparound, then you have to do it. Well, yeah, I guess you'd say 3u. Right? See how that works. Yep. Yes. Oh, because you get a float here instead of... Yeah. Yeah, because you're adding 5 and 6 to get 11, but then we're adding gravity to it, so it adds 9.82 or whatever it is, 9.81. Yeah. Yes, I think 20.81 is what you get-ish. Yeah. Yeah, so if gravity was an int, and it was just an engineer's gravity 10, then okay, cool, we get 21. But if it changes to be 9.82, later on we adjust gravity. Boom. I mean, maybe it's easier because all you have to do is say, hey, all the shit previously is auto, so if I wanted to make one of them a floating point, then all the things later that previously were doing int division would do floating division. Maybe you have logic that depends on that. You have a lot of changes happening. So it just depends on if you want those changes to occur. Generally safe. It can be helpful. De-emphasizing the type so that the logic... Sure, but I think the type information is important, and it's inherently important. Like, maybe it's better at some lower levels, but... Or you just need to be more often. I don't know. I don't really know when it would be better. When the type doesn't matter. Favor an explicit type. When you're for a type that differs from the initializer, yes. Or where the type needs to be obvious. I agree. Okay. I'm gonna close my eyes. I might fall asleep for a little bit, but if I wake up in time before real sleep time, then I'll go to bed. We'll find out. I wanted to do this earlier, but I couldn't because I had to tour apartments because I have to move within, well, get my lease locked in for the new apartment within 24 days because I need to provide 60 days notice to mine. So I'm operating on less time. And it means I'm outside sweating more, which means I need to fall asleep earlier. And I'm sitting in the comfortable ass chair, so it's tough. But I will resume when my stamina is regained, I'm hoping. Maybe. We'll see.